Hi, this is Miss Lee, and today's lesson is on solving multiplication and division inequalities with positive rational numbers. So in our previous lesson, we learned how to solve addition and subtraction inequalities, and that was pretty easy. We found out that it's basically just like solving an equation, except for instead of an equal sign, you have an inequality symbol. So let's go ahead and get started. Make sure that you are filling out your notes as we go through the video. Pause the video if necessary so you can stay caught up with your note taking. Okay, again, we've learned that solving an inequality is just like solving an equation. So let's go ahead and solve the inequality 6x is less than 12 and find what the possible solution set for x is going to be. We're going to start off with our models, and you can tell that the algebra tiles have already been modeled for us for this inequality. We have the 6 positive x tiles over on the left side of the inequality, and on the right side we have 12 positive unit tiles. Okay, and if you'll recall, what we want to do is we want to find out how many of these unit tiles are in 1x. Okay, not for 6x's, but for 1x. Since we have 6x's, we know that these 12 unit tiles need to be split equally into each x tile. And if I split my 12 into 6 equal parts, then that means each x tile is going to get 2. So this group of 2 units will go for this x tile. This group of 2 units will go for this x tile. This group of 2 will go for this one, and so on. So each x will get 2. So the value for x is going to be x. Bring down your inequality. It's not an equal sign. It's a less than symbol. X is less than 2. This is our solution. We need to check it. So we need to come back to the original inequality. 6x is less than 12. And we're going to replace the x variable with a value for x that is less than 2, because that's what our solution statement says. So I'm going to pick 1. 1 is less than 2. So I'm going to substitute 1 for x. So instead of 6 times x, I'm going to do 6 times 1, and that should be less than 12. When I do the math, 6 times 1 is 6, and yes, that is less than 12. So we solved it correctly. So again, it's just like solving the equation, using the models to solve equations. We just have an inequality symbol. And then you just have to check, make sure that you understand when you check it that you're picking a value that's less than 2, not equal to 2. Now, if we wanted to solve this mathematically without models, we can do that by using the multiplication and division properties of inequality. And these properties are the same as the addition and subtraction properties of inequality. You can multiply both sides of an inequality by the same positive number and the inequality will remain true. And you can divide both sides of an inequality by the same positive number and the inequality will remain true. So let's do a couple of examples. Our first one, 12x is less than 24. Again, I'm going to draw my line under the inequality symbol because I want to visually see that there's a left and a right side to the inequality. My variable, I need to isolate it. It's on the left side and it's being multiplied by 12. We need to undo that multiplication so that we can get x by itself. And to undo it, we have to do the inverse operation, just like with solving equations. The inverse means the opposite. What's the opposite of multiplying? Dividing. So for our division, I'm going to draw my division bar. You could use the division symbol, but you really need to get away from that and start doing it algebraically and using the division bar, like the fraction bar. We're going to divide by 12. Fairness rule says what you do to the left side or do to one side, you have to do the same thing to the other side. So we're going to divide the right side by 12. Now we do the math. 12 divided by 12 is 1x, or just x. Bring down my inequality symbol. And 24 divided by 12 is 2. So my solution would be x is less than 2. Let's check it. I'm going to go back, substitute a value that's less than 2. I'm going to choose 1 again. go back to your original inequality, 12 times, substitute 1 for x, should be less than 24. 12 times 1 is 12. Is that less than 24? It is, so we solved it correctly. And now we're going to graph the solution set. X is less than 2, so I need the number 2 on the number line. Since x is less than, my circle is going to be empty, and we're not going to fill it in because it doesn't have that equal line. And x is less than 2, which means it's going to go to the left. So this is my solution set for x. Okay, B, we'll go through the same process. Split up my inequality into a left and a right side. My variable is on the left side, but this time it's being divided by 3. So the inverse or the opposite operation of division is multiplication. So I'm going to show my multiplication. I'm not going to put a dot, I'm just going to put it in parentheses. Because remember, if you have a number next to something else that's in parentheses, it means multiplication. Okay. And then I'm going to do the same thing over here on the right side. Now we just do the math. This is the same as saying 3 over 1, if you want to put it in fraction form, and the 3's simplify to 1. So you get y over 1, which is just y. Bring down your greater than or equal to, and 5 times 3 is 15. Okay, let's check it. This time, let's pick a value for y that's greater than 15. Since our original inequality shows that y is going to be divided by 3, I find that it's easier to pick a multiple of 3. So a multiple of 3 that's greater than 15, I could choose 18. So I'm going to check it. 18 divided by 3 should be greater than or equal to 5. Well, 18 divided by 3 is 6. Is 6 greater than or equal to 5? It is. So we solved it correctly, and we can go ahead now and graph our solution. So we're going to have 15 on the number line. Because we have this equal line here, our circle is going to be filled in. And y is greater than 15, so it's going to go to the right. So as you can see, it's pretty easy. We're still going through the same steps, just like with the equations, we just have inequality symbols. So I would like for you to go ahead and work problem C on your own, pause the video, and try D as well. When you're done, come back and check your answers. Okay, let's see how you did. Take a look at letter C. Did you get that t is less than or equal to 56? If you did, great job. Here, t is being divided by 7, so to get t by itself, we have to do the inverse operation of division, which is multiplication. Multiply both sides by 7. Our 7's cancel out, leaves us t on the left side, and 8 times 7 is 56. And then check your answer. Again, we're going to replace t with some value that is less than 56. Since we're dividing by 7 in the original inequality, I want to replace it with a multiple of 7. So I just chose 21. And 21 divided by 7 was 3, and yes, that is less than or equal to 8. And this is what your solution graph should look like. Okay, for D, even though there's a decimal, you're doing the same process. This time, x is being multiplied by 1 2/10, so the inverse operation is to divide by 1 2/10. You divide both sides. This is where it gets tricky, and you have to remember what we learned first semester. We're doing 60 divided by 1 2/10. 1 2/10 is the divisor. You cannot have a decimal divisor. You have to move that decimal point and keep moving it until it turns into a whole number. In this case, we just needed to move it one time, and it turned into 12. So if you're going to move the decimal point one time in the divisor, you have to do the same thing over here to the dividend. So we had 60 was our whole number. Remember, on whole numbers, the decimal points are behind the number or to the right. And then you move it one place, and it became 600. So we had 600 divided by 12, which equals 50. And think about your integer rules. A negative divided by a positive is a negative. Be very careful, don't forget that. So our solution is x is greater than negative 50. How did you do on that one? If you have questions, please ask your teacher. And then this is the graph of what your solution set should look like. Ah, word problems. Okay, going from situations to inequalities. We want to write an inequality that represents this situation. So again, you're looking for those inequality clue words, those greater than, no more than, a minimum of. So it cost $660 to put on the school play. How many tickets T must be sold at $6 a piece in order to make a profit? Okay, so this is the clue word right here, and you kind of have to understand what profit means. The cost to put on the play is $660. So all this money you're earning from sales tickets, you don't make money until you make more than what it cost. That's what a profit is. If you make more money than what it costs to do something. So think about what that means in our inequality. To make a profit, we need to make more than the 660. So it needs to be greater than. Can it be equal to 660? No. That means you broke even. That means you just made what it cost. You didn't make any extra money. You didn't make a profit. So our inequality is going to be greater than 660. So we have the number of tickets, and they're sold at $6 a piece. A piece, what operation does that mean to do? It means to multiply. So we're multiplying 6 times t, and we're going to write it algebraically like this, and it should be greater than 660. So which answer choice is the closest or represents this? That would be C. And now from inequalities to situations. Which of the following situations could be represented by this inequality? 12y, which means 12 times y, is less than or equal to 144. Okay, the first situation. A rectangle has a maximum area of 144 square centimeters. If the width is 12 centimeters, what is y? The length of the rectangle. Now, you should recall this from elementary school. I know we haven't gotten to the geometry unit yet, but to find the area of a rectangle is going to be the length times the width. Okay, we know the maximum area is 144. Can it be greater than 144? No. So it's going to be a less than symbol here. Can it be equal to 144? Yes. And how do we find area? Length times width. The width is 12 and the length is y. So it's going to be 12 times y. And that matches. So 1 is an answer. There could be more than one, so let's go through our other 2 examples. One carnival ticket cost $12. The Flores family spent less than $144 at the carnival. Find y, the possible number of tickets the Flores family purchased. They spent less than 144. Did they spend exactly 144? No, less than. So we can actually stop right now because the inequality symbols are not the same. So 2 does not work. Let's try the third situation. The party store received an order to assemble at most 144 balloons into small balloon bouquets for a baby shower. Each balloon bouquet will have a dozen balloons. How many balloon bouquets Y will the florist make? All right, at most 144. Can it be more than 144? No. Can it be exactly 144? Well, at most means, yeah, it could be 144, just not more than 144. So far we're good. We have the same inequality, less than or equal to 144. So the balloon bouquets are Y, and each balloon bouquet has 12 balloons. Each means multiply. So this would be 12 balloons per bouquet. Should be less than or equal to 144. So this one matches as well. So 1 and 3 are possible situations for this inequality. Okay guys, nice job. You're ready for your independent practice.